Could the weight loss drug that everyone is talking about also be the fountain of youth? A new study just found that people taking semaglutide rewound the biological clock by an average of 3 years. But before we start adding longevity to the drug's resume, I think we need to talk about what those numbers actually mean and who they apply to. Welcome to the Nutrition Diva podcast, where we take a closer look at nutrition news, research, and trends, and answer your food and nutrition questions. I'm your host, Monica Reinagel, and today I want to address some of the buzzy headlines that you may have been seeing about the prescription drug semaglutide. It's better known by brand names like Ozempic and Wegovy, and its supposing anti-aging effects. The study that sparked these headlines was a 32-week, double-blind, placebo-controlled randomized trial. So that is the gold standard for testing whether a treatment has real effects. But here's an important detail right up front. The study participants were not representative of the general population or of the vast majority of people who actually use these medications. So this study involved adults who are living with HIV. And the trial was originally designed to see how semaglutide might affect lipohypertrophy. This is a condition that sometimes affects HIV patients, and it causes an abnormal accumulation of fat in certain areas of the body. And semaglutide was found to be quite effective in managing this particular condition. But after the trial was over, researchers then used some of the blood samples that they collected during the trial to do what's called a post hoc analysis, where they go back and take another look at the data or the samples that they've already collected to see if they can find any new or interesting patterns. So that might mean separating out subgroups of participants. Say only the women, or maybe only people over 50, and then reanalyzing the data for them separately to see if the results look any different in those narrower populations. Or it might mean looking at outcomes that weren't originally part of the experimental design. Now, because these weren't the original questions that the study was designed to answer, it's a lot more likely that any results that you do come up with could be due to chance. So, post hoc findings like this can be interesting and they're definitely worth following up on, but they really need to be confirmed in a new study before we can have a whole lot of confidence in them. So, in this case, the post hoc analysis had to do with assessing the effects of semaglutide on the subject's biological age using a variety of measures. And they found that semaglutide appeared to slow the pace of aging by about 9%. In fact, the participants measured about 3 years younger at the end of the study than they did at the beginning. More specifically, the results suggested that the drug shaved 5 years off the biological age of their brains and more than 4 years off their cardiovascular system, and improvements were also seen in kidney and liver function. Now, these are obviously pretty exciting findings, although I do want to note that as of now, this study has been made publicly available as a preprint. That means it has not yet undergone peer review or been accepted for publication by an established scientific journal. Nonetheless, that corner of the internet that I think of as the longevity bros, you know who I'm talking about, they are all over this, heralding GLP-1s as the next anti-aging superdrug. So how could a drug like semaglutide, which was developed to treat diabetes and is now widely used for weight loss, how could it possibly influence biological aging? And the most likely explanation is that it's acting on some of the same pathways that we already know contribute to age-related decline. Specifically, semaglutide treatment has positive effects on inflammation, as well as visceral fat and insulin sensitivity. And all of these are plausible mechanisms for slowing or reversing some aspects of biological aging. But before we declare aging a thing of the past, I think we need to step back and consider a little bit more of the fine print. When scientists talk about biological age, they're usually referring to how old your body seems to be based on certain biomarkers compared to your chronological age or the number of birthdays that you've had. So in this case, researchers used something called epigenetic clocks. These are tests that can detect shifts in biological aging trajectories over relatively short periods of time. And that's why they're so popular in anti-aging research. So these epigenetic clocks, they measure patterns in DNA methylation at specific sites along your genome. And over time, these patterns change in ways that tend to correlate with aging and disease risk. So there are several different types of these epigenetic clocks. And the study that we're talking about today used a whole panel of them. And all of them suggested significant positive, that is, anti aging effects. But there are a few important caveats. First of all, epigenetic clocks are surrogate markers. They're not direct measures of health span or lifespan. So one of these clocks might say that you're 3 years younger, but that does not prove that you'll live 3 years longer or even that you'll have fewer health problems. Secondly, the various tests that they are using for this are not very well standardized. So different research groups and commercial labs use different algorithms, and they may get different results on the same person. And finally, we know that certain DNA methylation patterns, which is what they're looking at here, we know that they tend to correlate with higher or lower disease risk and mortality. And that's why these clocks can be predictive of your health trajectory. But we don't yet know whether making those numbers better, as was the case in this study, whether that will necessarily translate into better health or a longer life. So while these epigenetic clocks are really exciting tools for researchers, we can't really use them to prove that something actually slows or reverses biological aging in a meaningful, real world way. And the other bit of fine print here has to do with the specific group that was studied. As I said before, all of the participants were people living with HIV. Now, as you're probably aware, we have made great strides in the treatment of HIV infection. With proper medical management, people with HIV can expect to lead largely normal lives with a life expectancy typical of others their age. But even with well-controlled infection, people who are living with HIV do tend to experience accelerated biological aging. And this is thought to be due to immune system activation and chronic inflammation. And it means that they are more prone to age-related problems like heart disease or cognitive decline. And these may show up earlier than they would in the general population. So because of all of this, people with HIV do provide researchers with a unique opportunity for testing potential anti-aging interventions. Because if something can slow or even reverse measures of biological aging in a population that's experiencing accelerated aging, well, that's a very hopeful sign. But it also means that the results don't necessarily apply to everyone else. So in this case, semaglutide may have been able to normalize an abnormal aging trajectory, but that's a whole lot different than turning back the clock for people who are aging at a more typical pace. And in fact, in their press release, the researchers do mention that another GLP-1 trial of generally healthy adults saw no age reduction. And they're apparently referring to another unpublished analysis. And this is why we need to slow down and separate the science from the spin. Semaglutide may indeed hold some promise as an anti-aging therapy, but to really prove that it works as well or better than other better established, not to mention cheaper approaches, we would need a lot more research. In other words, this is really intriguing science, but as is often the case, the headlines claiming that Ozempic can make you 3 to 5 years younger are way out ahead of the actual evidence. Now, that said, controlling inflammation, reducing visceral fat, improving metabolic functions, hey, those are all worthwhile goals for healthy aging, and you don't necessarily need a prescription drug to pursue them. And in fact, the safest and most reliable and most accessible tools we have are the ones that you've heard me talk about many times before. Eat plenty of vegetables and adequate protein. Exercise regularly and make sure you're getting a mix of cardio and resistance training. Get enough sleep. Learn to manage stress in a healthy way and work toward a healthy body weight and body composition. Beyond that, when you see those clickbait headlines claiming that any drug or food or supplement reverses aging, I want you to remember to ask, who was studied here and by whom? What were they measuring? And does that actually translate into better health or a longer life? If you have a question that you'd like me to answer, you can email it to me at nutrition@quickanddirtytips.com. And if you'd like to find out about having me speak at your next live or virtual event, you can learn more at wellnessworkshere.com. Nutrition Diva is a Quick and Dirty Tips podcast. Holly Hutchings is our director of podcasts. Steve Riekeberg is our audio engineer. Morgan Christensen heads up podcast operations and advertising. And a special welcome to Rebecca Sebastian, our new manager of marketing and publicity. Thanks also to Nat Hoops for his support. And most of all, thanks to you for listening.